All right, if you take a look at this, it says you have a tree growing vertically on a hillside. So we're going to start with the hillside, and that's inclined at 18 degrees to the horizontal. So that just means that the angle of the hill anywhere that you want from the horizontal is 18 degrees. I mean, we could have drawn an angle right here of 18 degrees. And it just means that your overall angle is 18 degrees. Okay, it says that this tree is growing vertically. Okay, so your tree is growing straight up and down, and it casts a 12-foot shadow directly up the slope. So here's the shadow of the tree. Okay, and we're told that that's 12 feet. Okay, finally, it says the angle of elevation of the sun is 68 degrees. So if we say that the shadow is formed right here, on which side, if you look at this straight line that passes through here, and this is the direction of the sunlight, right? It has to pass through and hit the tip of this tree all the way down to the tip of that shadow. So this line right here is the path of a ray of sunlight. Okay, and what it says is that has an angle of elevation of 68 degrees. Angle of elevation means the following. Okay, if you have an eyeball, okay, and it's looking straight across the horizontal, the horizon, the angle of elevation is the angle that it rotates to look up. Okay, so the rotation here, this angle measure, theta, is your angle of elevation. Okay, you also might see an angle of depression. An angle of depression would be if your eye was up high and it moved down to view something. Then this would be the angle of depression. I'll call it D. And so depending where you are, if you're on the ground looking up, it's angle of elevation. If you're up looking down, it's angle of depression. And it's all based on the horizon, or a horizontal line. And so with this, since the sun forms an angle of elevation of 68 degrees, what that means is you can do, again, anywhere you put a horizontal line on this, the path of the sun ray, this angle of elevation would be 68. So one of the easiest things to possibly do is if you extend that all the way down to the very bottom of your sketch, you have an angle of 68 degrees. Okay, so it's the angle if you were looking straight across this horizon and you rotated up to the sun. Okay, so to finish this off, if we took this tree and since it's growing vertically, if we were to sketch in a straight line, okay, this is basically what your sketch should look like. Okay, and you got a couple different ways that you can approach it. So the height of the tree, which I'll call H, is our unknown. This is what we want to solve for. So when we look at the triangle formed between these 3 points, okay, that's the triangle that we want to find. This is the triangle that we're going to use for this problem. Okay, so you know one side of that triangle. You have an unknown side. So let's see what other information we can identify using what we have. Well, if this is a right angle, can we identify what this angle is up here? It's what? 30. Not necessarily 30. 22. Why 22? Okay, if you take this whole triangle from here to here to here, it's a right triangle. So the 2 acute angles have to be complementary. And you know one is 68, therefore the other has to be its complement, 22. Okay, so we have this angle and the opposite side. We have an unknown side. Is there any way we can find the angle opposite it? And now there's a couple ways to do this, and this kind of comes to what do you see, what works for you. I'll show you the easiest one first. Is this angle is an exterior angle, correct? Right here. If you took this triangle and you extended this side, can you find what that angle is pretty easily? Yeah, just take the sum of the remote interiors. 68 plus 18 gives you a total of 86 degrees. Okay, so you can find the angle that way. And there's another way that you can find it. To me, that's the easiest way, but you might not see that one. If you don't see that one, you could also, if you were to sketch in a horizontal line here, what would this upper portion be? 68, right? Corresponding angles. And what would this lower portion be? 18 because of alternate interior angles. So once again, you're going to add those together to get your value of 86. So whichever way you use to find it, you're looking for that angle. Now, you could have also found this angle here by taking this small right triangle inside here, and once you find this angle, the vertical angle is equal, and then you can use triangle sum to find that. Again, there's multiple ways to come up with that solution. Okay, but once you have this information, do we now have enough to find our missing piece H? We have two angles and a side, AAS. And do we have a method for solving a non-right triangle with AAS? Law of sines. So if we took H over the sine of the angle opposite it, set that equal to our known side, 12, over the sine of the angle opposite that, you can now calculate your solution by multiplying both sides by the sine of 86. Okay, so again, if you took 12 times the sine of 86, all divided by the sine of 22, you'll get your solution, 31.9556 approximately. It asks you to, I guess it doesn't specifically, but so you'll round it. If I asked you to round it to the nearest tenth, what would your answer be? 32.0, and the units are feet. Okay. Are there questions on how I set that up or what any of the terms mean? It's possible.
Are you going to make us draw the picture too? Or are you going to give us
It's online, so it'll be very similar. Remember, your test questions will usually be really similar to what you see on the test prep. Yeah.
I just didn't understand how you got the 86.
Okay. All right, so if you have your hill and a tree growing on that hill with your 18-degree angle for the hill, the shadow is cast up the hill, so this is where the 12 came from. And because the shadow is right here, the path of a sun ray has to pass from the tip of the object to the tip of the shadow. And if we extend that down, we use the angle of elevation for that. And we can extend this vertical line through the tree down. Because it's vertical, it forms a right angle. So when you're looking for this angle right here, you have a couple different ways to find it. One is if I took this triangle of 18, 68, and here's the angle that we were finding. This is an exterior angle. An exterior angle of a triangle is equal to the sum of these two remotes. So if you add these two up, you get your 86 here. Now, you could have also found it, again, if you know that this is 68 and this is 18. If you were to sketch in your own parallel line right here, then corresponding angles are equal. So that upper portion is 68. Alternate interior angles of parallel lines are equal, so this bottom portion would be 18. So you could add them together in that way, too. Other questions on that problem?